Have you ever wondered why the ground sometimes shakes beneath your feet? It can feel a little scary or mysterious, but there's a fascinating explanation behind it. It's not magic or anger from the Earth, it's science in action. The ground moves because our planet is alive with energy and motion, even if we can't always see it. Deep below us, the planet is always moving, even if we don't notice it. The Earth's surface is made up of giant puzzle pieces called tectonic plates, and they're constantly shifting. Most of the time, these movements are tiny, so small we don't feel them at all. But sometimes, the plates get stuck and pressure builds up for years or even centuries. That sudden release is called an earthquake, a powerful shake that's been happening for billions of years. When the plates finally slip, all that built-up energy bursts out at once. The ground isn't one solid piece, it's more like a cracked eggshell, with huge sections slowly shifting. These cracks and pieces are what make earthquakes possible. Heat and pressure from deep inside the Earth push and pull these pieces, storing up energy over time. The Earth's core is incredibly hot, and that heat keeps everything moving. When that energy is finally released, the ground shakes. The vibrations travel through the Earth, making everything above it tremble and rattle. So next time you feel the Earth move, remember, it's part of a much bigger, exciting story about our ever-changing planet. Earthquakes remind us that our world is always in motion. Let's dig deeper to see what's really going on beneath our feet. There's a whole world of science and discovery waiting just below the surface. The Earth's crust is made up of enormous, rigid slabs known as tectonic plates, each one covering vast areas of the planet's surface like the pieces of a gigantic, ever-shifting puzzle. Think of these plates as the pieces of a global jigsaw puzzle, fitting together to form the continents and ocean floors we see today. These plates aren't fixed in place. They float on the slowly moving, semi-fluid mantle beneath them, drifting, bumping and grinding against each other over millions of years. Where these plates meet, at what we call plate boundaries, is where the real action happens. Here, mountains rise up, volcanoes erupt with fiery force, and earthquakes strike with little warning. Imagine pressing your hands together and trying to slide them past each other. Friction makes it tough, just like it does for the plates. The edges of tectonic plates are jagged and rough, so when they try to move, they often get stuck, unable to slide smoothly. As the plates push and pull, pressure builds up along these fault lines, much like stretching a rubber band, tighter and tighter. Eventually, the rocks can't hold the stress anymore, and all that stored energy is released in a sudden, powerful jolt. That's what we experience as an earthquake. The constant movement and friction at these boundaries drive most of Earth's geological drama, shaping the landscape and creating new features over time. Our planet's surface is always changing, thanks to these powerful forces working deep below our feet, moving continents and forming new land. Let's take a closer look at how this energy gets released and what happens during an earthquake. Picture two rough books pressed together. Try sliding them and they'll stick until suddenly they slip with a jolt. That's what happens with tectonic plates. Pressure builds, then releases in a burst. The energy stored in the rocks is called elastic strain energy. When the rocks finally slip, this energy travels out as seismic waves, vibrations that shake the ground. The spot deep underground where the slip starts is the earthquake's focus. The point above it on the surface is the epicenter. Shaking is strongest at the epicenter and weakens as waves travel outward. Seismic waves can even be detected on the other side of the world. Earthquakes are the dramatic result of years of slow pressure released in seconds. The ground beneath us is always part of this powerful cycle. Not all plate boundaries move the same way, and each type creates different earthquakes. The way these massive slabs of rock interact beneath our feet shapes the world above in surprising ways. At convergent boundaries, plates collide. Sometimes one slides under the other, causing deep, powerful quakes and building mountains. These collisions can also trigger volcanic eruptions and create dramatic landscapes over millions of years. At divergent boundaries, plates pull apart, letting magma rise and form new crust. These quakes are usually smaller. This process is most common along mid-ocean ridges, where new ocean floor is constantly being created. At transform boundaries, plates slide past each other, like the San Andreas Fault, causing strong, shallow earthquakes. These sudden shifts can happen without warning, making them especially dangerous in populated areas. Each boundary type has its own style of shaking and unique features. The size, depth, and frequency of earthquakes all depend on how the plates are moving. By studying these movements, scientists can predict where earthquakes are most likely to happen. This knowledge helps us understand which regions are at higher risk and why. Where the plates crash, pull apart, or slide sideways, their motion is the main cause of earthquakes. The energy released during these movements travels through the ground as seismic waves. The ground may seem still, but it's a stage for constant, powerful movement. Even when we can't feel it, the Earth is always shifting and changing beneath us. Understanding these boundaries helps us prepare for what's beneath our feet. With this knowledge, communities can build safer structures and plan for emergencies. The Earth's surface is always in motion, shaping our world. Mountains, valleys, and even oceans owe their existence to these powerful forces. Let's see how science helps us stay safe, turning our understanding of earthquakes into life-saving action. Understanding earthquakes isn't just fascinating, it's vital for safety. Scientists use seismographs to detect and measure seismic waves, learning where and how strong earthquakes are. This knowledge helps engineers design safer buildings and bridges. While we can't stop earthquakes, we can prepare for them and reduce their impact. Knowing what to do during a quake can save lives. Being prepared is key. The more we learn, the better we can protect ourselves and appreciate our dynamic planet. Science helps us understand and live safely on our ever-shaking Earth.